So welcome to video 7 in G08, our course on metagenomics in viruses. So here we're going to talk about using CheckV to assess metagenome assembled genome MAG quality. So CheckV is very, very useful because it can rapidly assess the quality of sets of contigs, either from viruses or elsewhere, but it's particularly focused on viruses. You can look at contamination for integrated proviruses in host genomes, look at completeness for genome fragments, identify closed genomes or complete genomes as well. So it works well in viruses. You can see the estimation error in different viruses that there is some error, but for most viruses, it's relatively low. So what this does is take a large pool of existing data using hidden marker models, HMMs, to cluster and assess the contigs that are submitted to identify ones that are viral specific or host. You see here that and to what extent they're integrated on the same contig, which is one of the key things that we'll look at. Also, they use information like GC content to explore that as well. So it can help eliminate provirus contamination in host contigs. It can look at gene annotation and quality across the whole contig, and also look at intergenic regions and look at these breakpoints between host and viruses. As you can see here, it can take information from existing databases to look at how complete the genomes are and use clustering methods to see how finished they are and give an estimate of how complete they are based on this clustering approach for different contigs. It does this at the protein level and looks at the contig length versus the match length for the top hit from these databases and has a confidence level associated with the outputs that it gets. So its accuracy may vary. And then if there's no match, it assesses the completeness based on the viral hidden marker models for that particular contig. It can also predict closed genomes, so you can look for direct terminal repeats to see if they're present, and complete viruses and inverted terminal repeats as well. And that can help to see if the genomes are fully complete. So these DTRs are typically repeated sequences that are near the start and end of a contig. That may indicate that the circular or linear genome is complete or fully present, or that end is fully present. For proviruses, this is the viral region with predicted host boundaries at the 5' and 3' end. And the same for DTRs and ITRs, depending on the organism of interest. Finally, you can put together a summary report on all these different things to identify how good the genomes are. If they're complete genomes, most of the time we'll find that it's rare to get complete genomes, and we're unlikely to do so in our practical at least. So what you can see here is as the summary table of the quality. The report is in a TSV format. You see here for contig 2, which is 42 kb, it has low completeness, so it's a mixture of host and virus genomes. It's low quality, and it's not very complete. And this is based on amino acid information that is present. Contig 3 is novel, so this contig is a provirus, and it's based on HMMs to predict how complete it is. And you also see that there's a Kmer frequency not shown here, which indicates the repetitiveness of the contig. You can see here key information in the tables on the prevalence of host and virus genomes on that particular contig. Completeness is another aspect, and this is based on the estimates of error and confidence associated with CheckV. So you can see that for contig 2 here, it has an expected length. So its observed length is 39.4 kb. The expected length is shorter, indicating that there might be a repeat inside there. Contig 3 has lower confidence, less complete, and its accuracy may not be as good. And for contact 4, we have no real information that is produced. So that's something we'd have to explore more. We can look for contamination, particularly for proviruses. We can see the contact ID1 is not viral. There's no provirus present. Contact 2 has a mixture of host and virus. You can see there's 2 host genes as well as 23 viral ones. You can see the host length and provirus length is the ratios given there. Contact 3 is a mix of host and virus, as is the much longer contact 4. So that might mean we need to explore better the structures of the contacts to make sure that they're correct. For the complete genomes, what you can see is that we have predictions for DTRs and ITRs in 4 of these, which is unusually good. The confidence level does vary. And for example, contact 3, we see multi-genome copies present. And the completeness for the first one, for example, is much higher than for the other ones. So the accuracy, confidence for the first contact is much higher, and with the other ones, it's definitely lower. So that completes this part on using CheckV. Please see the next video on metagenome functional analysis.